Hey everyone, today we'll be focusing on our second practice problem with queues by developing a linked list based queue, and without any further hesitation, let's get started. And now let's go over and build our queue from a linked list. So in order for us to be able to go about this, first thing we always need to do is that we also need to include our library. So we'll have include iOS stream in this case, and we will be as usual, using namespace std. So, first thing we're going to do is that since linked lists are comprised of nodes to be able to start with, the way we're going to build this is that we're going to go, let me just create our class first, and let's create our node using a struct, queueNode, and then int data, indicating the type of element that'll be going inside of our nodes, since linked lists are comprised of chains of elements altogether. And we'll be doing a singly linked list because it is considered more efficient in queues and stacks, since it's going in one direction rather than just going back and forth, considered in doubly linked list, and we're looking for a specific type of element. If you're using in the context between the two different lists, most likely when building the stacks and queues, focus on singly linked lists by general principle. That is what is more conventional. But anyway, focusing on queueNode right here, we're going to initialize our node. And the next part, what we're going to be doing, queueNode for the front, and then queueNode from the rear, because queues typically have a front, rear, and front and rear. Since we have the last element on the very end and the front element as well. Now I'm going to have a public instance, and I'm also going to put a semicolon here. So public initialize our class queue. This is how we initialize. So front, null pointer. We use null pointers for linked lists in general, and then rear, null pointer. Sorry about that. Now we're going to enqueue DQ. We'll check the front element. And check if empty. And then I'm going to have a function to display, much like what we did before. So first thing I'm going to do with the enqueue is that I'm going to have a function in this case. So linked lists are widely good for functions. Well, I mean, typically throughout the series in particular, we've been using void to be able to indicate the type of function you can use. You can use an integer, boolean, or a function. Right now, I'm just showcasing the different diversity of functions that you can use depending on how you want to be able to build your queue. So in this case, we'll use void enqueue int x queueNode, new node is equal to new queueNode, since we're calling upon the function over here to say, hey, let's create a new node in this case. Don't forget your semicolon. And if we don't have a new node, what we will be doing is that we are just going to say, hey, we can say queue overflow as an edge case, and L, and we can return just nothing right over here as a base case right here. So we just have to return as a placeholder. Now for us to be able to connect the new forms of data, we're going to have new node connect with data be equal to x, which is going to be considered an integer that we have. And we'll have new node next indicate as the null pointer just to initialize everything and make sure the chain has already been built up. So it's moving from one point to another as we are enqueuing our entire queue. Now, that we have already initialized x over here and have our null pointer, we'll be doing this for the rear, and then we'll be going for the front. So for the rear, if we are putting in a new node directly from the rear. We'll have rear next because of first in, first out, and indicate that as a new node. And then we set the rear to be the new node because of first in, first out. And then we'll have front as well as an edge case to indicate if it's not at the front, whenever we are enqueuing or dequeuing, then we're going to make the front be declared as the rear because of first in, first out. FIFO, as always. Now, next part, we're going to be dequeuing by using an int DQ. And if the element we were looking for is not in the front, or if there are no elements really, we're just going to say Q underflow and L. And since we are dealing with integers, we'll have return -1 in this case because we're doing a DQ, and then we'll have Q node temporary by doing a swap technique. Swap techniques are widely popular for linked lists. Front and then will be equal to front next, and then if there's nothing directly at the front, we're going to be doing the opposite and go rear equals null pointer, and then int DQ'd is equal to temp data, and then we'll delete the temp and return our DQ'd, indicating the exact element that we have DQ'd throughout the rest of our queue. Now we're going to check the front element, and the way we do so is going to be the following. So this time I'm going to put an integer in this case. I'm going to call it front element. And if the element that we are going for is not the front and is not there, we indicate that the queue is empty. Then we'll have end L. And finally, return -1 because we're dealing with integers. And we'll have return front data. So we're getting the exact data inside the front element that we have because we're dealing with a linked list. And I'm going to check to see if this is empty by doing a Boolean condition. Is empty, and that means we return true in this case if the let's say the return front is equal to null pointer. Mainly because since we are dealing with a linked list, we have to focus on the chain really compared to the previous iteration that we have for our array, because our array has a fixed size of elements. That's why in particular for size it would be indicated as 0, but since we're focusing on the data in of itself, the logic would be different, immensely different in this case. So actually I would get rid of these parentheses over here. Since we're dealing with the chain of elements already hooked up together and linked lists are comprised of a head and then a series of nodes to follow through, we always check the front element first, indicating if there's nothing there. If there's nothing there, then therefore it is considered empty. And then the function display, I'm going to go void display if is empty. Elements frowny face because it's funny. And L. And then I'm gonna have Q. You can always return for function just by good principle. And Q node temp is equal to front. And since linked lists always start with the head and a series of nodes, we go with the front, and then we're going to output all of the elements on the inside of the linked list. So that means we will be doing temp doesn't equal null pointer, because we're going to be checking the next iteration for each one. For we declare temp as the front, and therefore going through each one. While temp is not equal to null pointer, that means we are going to get the data specifically inside of the linked list. Data. And then we'll have temp equal to temp next. And then count end L. Actually, you can just leave it as that. Or you can just do this. Yeah, that should be fine. Yeah, actually by good principle, it should be good right here because we are dealing with the front element first, and then we're printing out the rest of the data accordingly until we actually reach the very end. So it's good principle to be able to have this. All right, now we're going to test this bad boy by int main. First thing we're going to do, declare a class. We're going to enqueue, display, pop elements from the queue, and further display. So we declare a class by doing queue. So this is what we call. So we're going to have queue dot enqueue. I'm going to put 10, 20, 30. Then we'll display. So I'm going to do queue display. Then we're going to pop an element from the queue by doing count popped, or I should say DQ'd element from the queue. Queue dot DQ and now count queue dot front element is our front element. And for the display, other elements in the queue. Queue dot display. Let me return 0. Let's build this and make sure this works. All right, and see the errors right here. Feel free to take a screenshot of what we have done. I'm going to go slow for a second. All right, now I'm going to run this. Yep, so we have 10, 20, 30, DQ from the element, looks like 10, that's right, because it goes from the front. 20 is our front element, therefore, and further elements that we have in our queue are going to be 20 and 30. And it looks really efficient, looks very clean from what we have already done. All right, so yes indeed. So this was our queue-based, well, this is our linked list queue. Yeah, linked list based queue in general. And so yeah, this looks pretty good. Just get it right here. There we go. Hey everyone, thank you very much for taking time to watch this video. If you found this video helpful, be sure and feel free to please like and subscribe. And if you have any other questions as well, feel free to put it in the comment section. And as always, take care. Cheers. Bye-bye.